Our second objective for this lesson is to be able to apply function notation. So when a function is defined by an equation, see example 4. So in example 4, we had a function that was defined by an equation. The y is equal to 2x plus 6. We will often use function notation. So for example, instead of writing y is equal to 2x plus 6, we can write that f of x is equal to 2x plus 6. And that's how we read that. F of x equals 2x plus 6. F is the name of the function. X is the independent variable, and that's coming from the domain. And f of x is the function value. That's the same as the y value that we get that corresponds, that matches up with our x. So let's see how we evaluate these functions for given values of x. Example 11a, we have the function f of x equals 2x squared minus 3x plus 1. F of negative 3 means to plug in x equal negative 3 and simplify. So f of negative 3, I'm going to be replacing all of the x's with negative 3. So first I'm just going to rewrite the equation or the function, and everywhere that there's an x, I'm putting a blank spot. So I have 2 blank spot squared minus 3 times a blank spot plus 1. And then in those blank spots, we're going to be plugging in negative 3. And those parentheses are important. You have to be careful when we use parentheses to square negative numbers. 2 times negative 3 squared is 2 times positive 9. Negative 3 times negative 3 is a positive 9, and then we're going to be adding 1. This gives us 18 plus 10, which is 28. So notice that we're not solving anything there. We just plug in negative 3 and simplify. For part B, f of capital A, same thing. I'm going to be replacing these x's with capital A. So f of capital A is equal to 2, instead of x squared, it's capital A squared. Instead of minus 3x, it's minus 3 capital A. And then plus 1. There's nothing to plug in there. That is our answer. We simply replace x with whatever is on the inside of the parentheses. Here, I'm going to be plugging in 3 plus z. So I have 2 times 3 plus z squared minus 3 times 3 plus z plus 1. Notice how I'm using parentheses there. Let's do some algebra to simplify this. We would need to FOIL out that 3 plus z squared, so we would have to do 3 plus z times 3 plus z and do first, outer, inner, last to expand that out. We would get 9 plus 6z plus z squared. If you're wondering where I got that from, expand this out and combine like terms. I'm going to distribute this negative 3 to give me a negative 9 minus 3z plus 1. Distribute the 2. We have 18 plus 12z plus 2z squared. And now I'm just going to bring down everything else, and then we're just going to combine like terms. We have a 2z squared. We have a 12z and a negative 3z, which will give us a positive 9z. And then we have 18 minus 9 plus 1, which will give us a plus 10 to get our final answer there. Looking at example 12, we have 4 different expressions we want to evaluate here. Same thing, we are going to be plugging in these values into the function. So for g of 3, I'm replacing this x with 3. So I have the square root of 6 minus 2 times 3. 2 times 3 is 6. 6 minus 6 is 0, and the square root of 0 is 0. For g of 4, we have the square root of 6 minus 2 times 4. Plug 4 in for x. 2 times 4 is 8. 6 minus 8 is negative 2. We cannot take square roots of negative numbers. G of 4 is undefined. You cannot put a negative number under a square root. Please be careful with your notation here. The answer for example 12b is not no solution, because we weren't solving anything. We were just trying to evaluate something. And what we were trying to evaluate was not defined. So we say it's undefined. Notice, when we try to plug 4 in, we get that negative number under the square root to get that this whole expression is undefined. So what that tells us is that 4 is not in the domain of G. Because when we try to plug 4 in, we don't get an answer out. We end up being undefined. So 4 is not in the domain of G. Let's look at G of negative 4. So this time I'm going to be plugging negative 4 into the function. So I would have the square root of 6 minus 2 times negative 4. 2 times the negative 2 and the negative 4 will come together to give us a positive 8. So we get the square root of 16, which is defined because 16 is positive. That's a positive 4. By the way, if you know about imaginary numbers, you may have been thinking, well, why didn't you just put an I for 12b? If you don't know what I'm talking about with imaginary numbers, that's perfectly fine. Right now, we're only working with real numbers, okay? So we're talking about real functions with real values that we could really graph. We cannot graph imaginary numbers. We will not be answering function evaluations and giving our answers in terms of imaginary numbers. Okay, if you're getting a negative number under an even radical, that is undefined. For 12d, g of p minus 1, I'm going to be replacing x with p minus 1. So I have the square root of 6 minus 2 times p minus 1. Make sure and put parentheses around that p minus 1 when you plug it in for this x, because we need to distribute that 2 under that square root to give us 6 minus 2p plus 2, which is the square root of 8 minus 2p. You could have also wrote the square root of negative 2p plus 8 would have been fine. Okay. Finally, example 13, we have 3 more evaluations to look at. H of 2, we're going to be going into this t and replacing it with a 2. So we have 4 over 5 minus 2, which is 4/3. That's defined, that's our answer. For h of 5, we have 4 over 5 minus 5. That's 4 over 0. We cannot have 0 in the denominator. 0 in the denominator is undefined. Okay, that's our answer for 13b, undefined. We cannot have 0 in the denominator. That tells us that 5 is not in the domain of h, because we can't plug 5 in. When we try to plug 5 in, we get undefined. So 5 is not in the domain. For h of t plus 1, we're going to be going into this expression and replacing the t with a t plus 1. So we have 4 over 5 minus t plus 1. Be careful here. This is written incorrectly right now. You need to put parentheses around that t plus 1 because you have to distribute this minus sign to both of those terms to give you the final answer of 4 over 5. Well, it's not the final answer yet. Minus t minus 1. We got to combine those like terms in the denominator. 5 minus 1 is 4, so we get 4 minus t. And no, we cannot cancel those two 4s. If you try to cancel those 4s and tell me this is 1 over 1 minus t, that's wrong, okay? You would need to have something in common with all 3 terms in the fraction, which we do not. So we cannot simplify anything there. So we've looked at 3, 6, 10 examples in total, all these parts, of doing function evaluations. Key takeaway here, make sure to use parentheses when you're plugging things in, especially if what you're plugging in has more than one term. Make sure to use parentheses so that you know how to distribute, like we had to do over here. We had to distribute this negative here. Like we also had to do over here. We had to distribute this negative too. So those parentheses are important, especially when we're plugging something in that has more than one term. Also, what was important, in example 12b, we saw that negative numbers under even radicals, and what I mean by even radicals is the square root has an understood 2 right here, but we don't typically write it. Negative numbers under even radicals are undefined. In example 13b, 0 in the denominator is undefined. Okay, in all these problems we were not solving, we were plugging something in and evaluating.